Okay, hello YouTube. Let's swap over like that. How are you all doing today? I'm doing pretty good. Yeah, no, pretty excited for a bit more Dart today. Last time I looked at functions, just did some simple functions, nothing exciting. Today, going to be looking at some operators and some statements. See how far we get. You know, might do a lot, might do very little. Let's get stuck in though. Let's swap over to here. There we go, and we've got our code from yesterday. Let's take all of this out like so. And like so, and just leave our main function in there. Okay, let's go over to the documentation. Let's zoom in so we can all have a bit of a read. Is that too much, or nah, that looks pretty good. My my browser went a little bit mad there. Can I I've lost where I was now. Hang on 2 seconds, I've got to zoom out now. Let's jump to something about zooming in and out really makes my computer chug. So we want to go to operators. Okay, fantastic. Let's zoom in. Zoom in again. 250. 300. Okay, that looks good. That looks good. So, operators. Dart supports the operators shown in the following table. You can implement many of these operators as class members. Let's not get into classes just yet. Unary postfix. So here we have increment and decrement as well. Cool. Unary prefix. And this is the order. So this increments before, this increments after the action is taken on the expression. This one increments before the action is taken on the expression. Awesome sauce. Await expression. Not sure what those are, but we'll probably find out. Multiplicative. So I'll multiply, divide, modulus. Is that divide into an integer or something? It's like you divide and then you get an integer out of it, something like that. Additive, plus minus, shift, bitwise shift, and exclusive or so ampersand, caret. Is that one a caret? I think that's a caret. And pipe for or. Relational and typeset tests. Greater than or equal to, greater than, blah, blah, blah. As is and not is. Equality, so is equivalent to or not. Logical and, we have a bitwise and a logical and. Logical and, logical or, if null. Conditional. Expression 1, expression 2, expression 3. Cascade, ... I'm not sure what cascade is, to be honest. And assignment. So we all know equals as the basic assignment, but we've interestingly got a multiply assignment, divided. I'm not sure what these are. And assignment, caret assignment, extra, etc. Okie dokie then. When you use operators, you create expressions. Here are some examples of operators. Okay. In the operator table, each operator has a higher precedence than the operators in the rows that follow it. For example, the multiplicative operator modulo has higher precedence than, and thus executes before, the equality operator, which has higher precedence than the logical and operator. That precedence means that the following two lines of code execute the same way. Okay. So it's a bit like the old BODMAS stuff, right? Brackets over division, multiplication, addition, subtraction. Cool. Okay, so here we have some stuff. Add, subtract, unary, minus, also known as a negation. Reverse the sign of the expression. Multiply, divide. Yeah, divide, returning an integer result. Yeah, that's what I was talking about. So, I guess what would be an example? 10 divided by 6 would give you 2, I think. Not entirely sure, to be honest. I'm making that one up for sure. And modulo, get the integer division, get the remainder of an integer division. So 5 integer 2. Okay, yeah. So it like does a rounding after that. That also supports both prefix and postfix increment and decrement operators. Okay, cool. Expression value is var minus 1. Expression value is var. These two things look exactly the same. Like that. Not entirely sure. So here's something like int b in a equals 0, b plus a increment before b gets its value. Assert a equals b. Okay. I'm not sure I'm going to go through increment and decrement and that stuff. I think it's so prevalent in other languages. I don't think I need to sit there and have a lesson on it. Hence why I put a second subject in this one. Because I was like, I'm pretty sure I'm going to get through this. Not equal, greater than. Okay, yeah, cool. Usual stuff for comparative. Equality and relational operators, as they call it. To test whether two objects x and y represent the same thing, use the equals operator or equality. Do they call it equality? Equal. Well, right. If x or y is null, return true if both are null. False if only one is null. Okay, let's actually skip down to because I think this is actually more interesting and a little bit more sort of the typecast and the is, I think, has a little bit more meaning to it and a bit more usefulness to it. I think, I guess if there's a thing of operators, I think probably a lot of people have explained it better than me, and I'm not sure if I can offer anything really on that one. Short of these tables, you just go through, and I probably would say a million things what other people say, which is, this is you've got an increment, which is just if you've got a 1 and then you do plus plus, then that becomes 2. Whether it becomes before and after is whether the thing is done to the expression before or after the decrement. So this would increment and then do the expression. This one do the expression and then increment. This one's going to be way more popular because that's what you use in loops. Again, I've explained that terribly. This is why I don't think I should explain it. I think I should just leave it. But yeah, I think I'm going to skip through this and get down to the other ones. So as is and is not, isn't operators are handy for checking types at runtime. As typecast users also used to specify library prefixes. True if the object has the specified type. True if the object does not have a specified type. The result of object is T if true if T implements the interface specified by T. For example, object is always true. Use the as operator to cast an object to a particular type if and only if you are sure that the object of that type. Employee as person, dot first name Bob. If you're not sure that object is of type T, then use is T to check type before using it. Okay. So I'm not sure how I could actually practice that, to be honest, because these already have things, you know, because you could do is string, I guess. Would that be a thing? So I could say name Dom and just do a quick assert. I quite like this assert. Name is string. Oh, I haven't. Var. Okay, hasn't. Yeah, I mean, it's already saying it, that it's unnecessary because it's checking that, because this will always be a string. Can't be used as an expression. So let's do this, run. We should get true. True, there we go. Simple as. So you can check if one thing is another thing. I wonder if I can... Oh, whoops. Do that. Nope. Yeah, expected a type. So I guess when you're getting into types, and then, you know, you could have a class that is, you know, a user. You can then say, oh, this is what this is. You know, you could say, oh, if I have an instance, I could say, is this instant of this? I assume that's what I'm doing. But I can't really test this or have a go at it, because I can do the type check. I've just done that. Gave back true, so I could do an if. And then you can see this type, employee.firstname. So that would come from some form of class. The code isn't equivalent if employee is null or not a person. For example, throws an exception and the second does nothing. Okay. Assignment operators. As we've already seen, you can assign values using the equals operator. To assign only if the assigned to variable is null, use the null operator. Assign value to B if B is null. Otherwise, B stays the same. Okay. Compound assignment operators such as plus equals combine an operation with an assignment. So if A equals 5, let's say B is 4, like so. Then what it's saying is C, I could say plus equals no, actually if I do B plus equals 3, like so, and then print b expected an identifier. All right, what did I do wrong there? A equals a plus b. A equals a plus b. Because that should be b equals b plus 3. Okay, yeah, whatever. That's not used. Expected an identifier. I mean, that's exactly what I've done here. So what have I done wrong here? Seriously. B is already declared in this scope. The name B is already defined. But I've sort of defined it up here, like, why is it now not reassigning? Surely that's the fucking point, right? Or, oh, my browser having another bit of a mare. Uh-oh. Getting a big old not responding here. Let's take a moment. Okay, cool. So maybe I have to do it like this. There we go. So without the var, so I'm actually not explicitly assigning it and just saying like, oh, okay, well, B, this is essentially B equals B plus 3. So when I print B, I get 4 and then 7. Well, I can do A, like so. 9. There we go. There we go. That's that. Logical operators. You can convert or combine Boolean expressions using logical operators. Inverts the following expression. Yep, logical or, logical and. Yeah, I mean, standard stuff really. And or, what would be exclusive or? Did they have that one? I feel like they did. Hang on, let's scroll back up. Not really, actually. They've got it for the bitwise, but they don't have an exclusive or for this. Oh well. Let's go back down. Where are we? Where are we? Here we go. Not much in that one, but we could have a go. I think it's sort of standard stuff. Where we could say essentially if A is less than 10 and B is greater than 2, which is true, then curly braces. Oh no, wrong one. Let's get rid of that because I'm going to continue to do that. Yeah, curly braces. Print Oh, yes. Oh, I forgot my semicolon. Okay. Oh, yes. Oh, yes. So if I change this now to, I said A is less than 10, so let's do A is less than 3, so that should not give me anything. There we go. So I could put an else here. And print oh no. Oh no. There we go. Logical operators. Aren't they fun? Bitwise and shift operators. I'm actually going to skip past it. I've never had to use a bitwise before. I know of it. And I think that's enough. When I need it, I will look it up. Come back here. Conditional expressions. Dart is two operators that let you concisely evaluate expressions that might otherwise require if-else statements. Okay, so this is back to that one-liner thing that we had with functions that I quite liked. If condition is true, evaluates expression 1 and returns its value. Otherwise, evaluates and returns the value of expression 2. If expression 1 is not null, returns its value. Otherwise, evaluates and returns the value of expression 2. When you need to assign a value based on a Boolean expression, considering using the question mark and colon. So this is like the one-liner function, but it does the one-liner function and then says like name. What did this say this was? Test for null. Okay, so test for null. Guessed. Okay, yeah. If name is not null, name is guessed. Player name string name. Okay, yeah. So, okay. So let's go with our example here. And we can create another var C, for example. And then I'll do my condition. So yeah, condition question mark expression 1 colon expression 2. So condition will say if A is less than 3, my first expression will be let's go yes, and then let's go no, like that, and then we'll just print C like so. So is A less than 3? No. Let's make this 2. Is A less than 3? Yes. So if you're doing a quick check, that's actually really nice. Again, there's a few concise things that I quite like about it. And that's quite a nice one because, like it was saying, it's the equivalent of saying if A is less than 3, then C is equal to yes, else C is equal to no. Whoops. No, like that. And that's this and this are the same thing. But this is a way more concise way of doing things. And there's a lot of situations where you do actually do very quick things to sort of say, oh, is this thing, a string? Is this thing null? Is this thing, whatever? And then all you want to do out of it is just a very small, like, oh, it's kind of like a toggle. So you want to say, oh, is this thing on? Like, for example, if I was like, to give an example, let's sort of get rid of this. Let's get rid of this. And we'll call this switch state, for example. And we'll say on. And then what we could say is var action equals condition. So switch state equal to on, and then the expression for it, if it's on, would be turn off, and then this otherwise would be turn on. So this would be like a toggle switch essentially. And then we'll just quickly print out, we'll use our string interpolation, you need to action, like so, and then polish that off like that. We'll get rid of this. Okay, and then run. You need to turn off, but if I change this to off, you need to turn on. So that's an example of a what am I trying to say? Of a toggle switch, right? That's actually a very simple operation of that. I can just toggle things on and off without having to go through and say like, well, what is the state right now? Cool, do the opposite. It's just easy to sort of say, is it on? Turn it off. And if it's not on, if it's not on, yeah, right, not off, but not on, then turn on. Okay, excellent. I like that a lot. Big fan of that. Cascade notation is next. Dot and question mark dot allows you to make a sequence of operations on the same object. In addition to function calls, you can also access fields on the same object. This often saves you the step of creating a temporary variable, and allows you to write more fluid code. Consider the following code. The constructor paint returns a paint object. The code that follows the cascade notion operates on this object, ignoring any values that might get returned. In the previous example, the equivalent code is... Okay, so this makes it contextually aware to the thing that you've just done. If the object cascade operators can be null, they use the null shorting cascade for question mark dot dot for the first operation, starting with question mark dot dot. Guarantees that none of the cascade operations are attempted in that null object. You can also nest cascades, for example. Be careful to construct your cascade in a function that returns an actual object. For example, the following code fails. Okay. All right. I can't really do this until I have a class, I guess. Because that's obviously created an instance, and then it's just gone in and said, okay, in that instance, for name, assign this, for email, assign this, for phone, call another class with an instance, and then add number to the phone number instance and a label to the phone number instance. And then finally it calls a function of build. And then at the bottom, build again. So these are all class-based things. And I think as we haven't got any classes, whatever, let's leave it for now. Control flow statements. And I think, we can go through some of these if-else stuffs and call it after that, I think. But there is some interesting stuff in there. You can control you can control the flow of your Dart code using any of the following: if else, for, while and do while, break and continue, switch in case, assert. You can also affect the control flow using try, catch, and throw, as explained in exceptions. Dart supports if statements with optional else statements, as the next sample shows. Also see conditional expressions. Unlike JavaScript, conditions must use Boolean values, nothing else. Okay, so that's quite interesting, because in JavaScript you can I think in other languages as well, you could just ask you could put a statement in, like 1, for example. In Python you could put 1, and then if you say if 1, it takes 1 meaning true, it takes 0 meaning false. But this says you explicitly you must use Boolean values. And to be honest, when I code, I tend to convert everything to Boolean before I go into my statements. For clarity, I've got a terrible memory as well. It really helps me sort of figure out what's going on. So that is okay for me. I'm happy with that. And we just did an example of one, right? Not so much here, but the one previous. So, all happy with that. For loops. You can iterate with the standard for loop, for example. String buffer. Oh, string buffer gives me that, does it? Okay. Let's copy all of this and just dump it in. Like so. Oh, no. Like so, and run it. Message.write? What is message.write? Should we say... Yeah. Or if I change that to print. Why does it do that string buffer? I don't understand. You can iterate with a standard for loop. Oh, right, so it enters that into a buffer and then... Oh, and then it calls message.write. But that didn't actually do anything. I don't know. What if I print message here? And then run. Oh no, did not mean to do that. did not mean to do that at all. Oh, here we go. Yeah. Okay, so it just adds that in. Cool. Sound. Again, the JavaScript. I hate this so much. Like, it's so standard in JavaScript, but I hate it so much. It's so verbose for you know what you want to do. But I know in here for a fact that you can do this. Let's kind of go back up and see what this is saying here actually before we jump down there. Closures inside of Dart's for loops capture the value of the index, avoiding common pitfall found in JavaScript. The output is 0 and then 1 as expected. In contrast, the example will print 2 and then 2 in Java and then 2 in JavaScript. And then here we go. Here we get to the meat. This is how I like to do it. If the object that you're iterating over is an iterable, such as a list or set, you don't need to know the current iteration counter. You can just use the for in form of iteration. Like so. So this is kind of what I'm more familiar with in Python. So you can do var names and then Dom and Alison and Dave, like so. And then you can say for name. This has to be in this though, doesn't it? In names, print name, and then this I need to var, I guess. Whoops, like so. And there we go. Nice and simple. This is so much cleaner. And they use final in that example. Still works. To practice using for in, follow the iterable collections code lab. There's final there again. So some interesting stuff in there, to be honest. But let's move on. Iterable classes have a for each method as another option. Do you know what JavaScript's got this as well? And this, for my last video, I was kind of confused about anonymous functions, but this is where it can come in really useful. Because basically when you do this collection for each, print essentially says just print it, you know. So I could say names dot for each and then print to make it even more concise, because we like conciseness. But I could also create an anonymous function. So I could say name, or even better, string name, like so, and then do that, and do print hello name. And that's going to bug out on me. totally got that wrong. I forgot how to do the anonymous function. Do I have to write function? No. I've messed it up. So that is with that. That's with that. That. Oh, there's an extra one there. Oh, let's try that. Oh, there we go. That worked. I had an extra bracket, an extra parentheses in there, but that actually worked. So the for each needs a function, and then you do your one-liner function. So you create your argument to the anonymous function, and then you sort of say, "Oh, do a thing," right? So we can see that does the same as if we were to say for name in names, like so, print hello name, like such. And I need to do final. I don't know, final is better than var, no idea. But these two things are actually the same. And there you go, you get the same result. So these two things are equivalent to each other. This is quite concise, kind of like it. Bit of a fan. We'll see how it goes when I actually get into writing code. I might default to this just because of habit. So cool. Do while loop. A while loop evaluates the condition before the loop. So while something is true, do something. Equally, do while loop evaluates the condition after the loop. Yeah, I mean, pretty standard stuff, really. I find I don't really use do while loops very often. No reason really to hate on do while loops, but I just never really find a reason to use them. Yeah. Use break to stop looping. While true, if shutdown request, break. Process incoming requests. Okay, so just, yeah, usual stuff, break to come out of the do while. But again, I'm going to skip over it because I don't really use it very often. Use continue to skip over the next loop iteration. Okay, so that's just like using pass in Python, where you just kind of want to say, forget it, go to the next thing. So if I was looping for a list, for example, and I was like, I only care about names above 3 letters, for example, I could say if a name is greater than 3, then print hello name, like so. And then in my else, you wouldn't actually do this, but continue. But it would be pass in Python, essentially. So in this case, I don't want to do this. Whoops. Name dot length. There we go. There we go. And then on that second one, it dropped out my name because it's 3 letters long. But when it gets to my one, it's not going to bug out. It just goes to, if it's this, no, it's not that, then go to else, and it just says, just go to the next one. Like, don't need to do anything. So, cool. Continue is pass, is just what I need to remember from a Python perspective. You might write the expression differently if you use an iterable, such as a list or a set. Candidates where for each, where c.use experience is less than 5. Okay, so that's the condition for the if statement. Okay, very concise, but I don't think this is readable. I like the other concise stuff, but for me, I'm not quite winning over on that one. Candidates where that for each. not loving that too much. Switch statements and data compare integer, string, or compile type and constants using the equal operator. The compared objects must be instances of the same class, if not of its subtypes, and class must not override. Enumerated types work well in switch statements. And I was going to say, like, this is all enumerated stuff. Quick reminder, enumerated is a fixed list of things that you're going to come in with. Think of it like a drop down that has, small, medium, large. Small to medium, large, therefore would be an enumerated list because you're not intending to add anything to it or take anything away, and you use it as a point of reference. Each non-empty case clause ends with break statement as a rule. Other valid ways to end non-empty case clauses are continue, throw, or return statements. So I'd use small but large, but this is like var command is open, switch command, case closed, do something, pending, do something. Okay. Switch case, standard stuff, like standard stuff. I'm not going to really go hugely through it. Mainly because I just, there's a lot of stuff I'm skipping over, and I think the reason is that it's familiar, and really what I want to know is where am I lacking, what do I not need to do, and I think switch case is something I use rarely, but I do know how to use it. I do understand its concept, and in these cases I can sort of just come back and say, I can just come back and figure out what these things are as and when I need them. Really what I want to do is get to the point where I am making more sense of the language generally, so I can kind of get into the more Flutter stuff, really. And this is sort of the weird thing about cases as well, is like you get to this weird stuff where you're just like, if and else if kind of becomes a little bit more sensible. Assert during development using assert statement to disrupt normal execution if a Boolean condition is false. You can find examples of assert statements throughout this tour. Here's some more, and we've done a load of this stuff where you can just stick a check in and say, right, stop doing what you're doing, and that's actually hugely useful. I'm a big fan of that. Okay. And let's have a look at exceptions. Let's chuck in exceptions as a quick bonus, and then we'll call it a night. Because it is nearly 1 a.m. for me. So, probably should go to bed. Your dot code throw and catch exceptions. Exceptions are errors indicating that something unexpected happened. If the exception is not caught, the isolate that raised the exception is suspended. And typically the isolate and its program are terminated. In contrast to Java, all of Dart's exceptions are unchecked exceptions. Methods don't declare which exceptions they might throw, and you aren't required to catch any exceptions. Here's an example: thrown or raising an exception. Copy. Let's put this in here, like so. There we go. Expected at least one section. Okay, cool. You can also throw arbitrary objects. So I could just say throw, wait, this is me. And there we go. Cool. Because throwing an exception is an expression, you can throw exceptions in arrow statements as well as anywhere else that allows expressions. catching or capturing an exception stops the exception from propagating unless you rethrow the exception. Try an exception gives you a chance to handle it. Yeah. Try. So I have to build. So you build an exception case essentially, and then you say, yeah, okay. And try except. This is way more what I'm familiar with in Python. And then finally to clean up. Okay, yeah, I think that's fine. And I think, I've massively gone quickly through that, but again, it's stuff that I think is very familiar. I think if you come from another language, you know all this stuff. There's a few useful bits in there. And try except. This is, I think, my number one. This is kind of what I do more than anything else. But I can look at these other ones and see how they appropriately go in. But chucking a bunch of try excepts aren't exactly the best practices. And yeah, I think that's kind of finally is actually very useful. Calls to runs after matching case clauses. Yeah. So try, catch, do that thing, and then finally at the end do all that. Clean up. Is that what it is? And afterwards the classes, which maybe tomorrow, not sure. I'm deciding between classes and maybe doing some web requests. So I think if I get some web requests going, then I can get to a few more interesting things. So I can sort of run a piece of code, get some live data, do something with it, reformat it or whatever, and then stick it out so I can do something else with it. But might do classes, and I guess I'll decide tomorrow. See how I feel, But it's either going to be classes, then web requests, or web requests and classes. One of the two. But this is the last thing, and I think appropriately we finished on the finally. I think that's very, very appropriate. But yeah, that is day 3. An hour a day, that's essentially what I'm doing. And it's not really a lesson this. It's not really a tutorial. It's merely my journey going through learning Dart and eventually getting onto Flutter. And it's just a way of me showing my work, really, and sort of saying, this is how I got here. And then maybe somebody might come across and say, oh, that was hugely useful. Who knows? If it was useful, stick it in the comments, because I'd love to hear it. And my door is always open, so ask me anything. But apart from that, I think we're good. I think we're done. And it's exciting learning this new language, and it's exciting finding these new things, those little concise things I really, really like. And maybe that's sort of a piece that I miss out of JavaScript. I generally don't like doing JavaScript. I just find I'm always forever bringing in new libraries, bringing in new frameworks, some other way of trying to figure something out. So I'm not a big fan of it. But, moving forward, we could, really see how Dart and Flutter open up and what's possible. Who knows? Anyway, that is me. Definitely too late. Definitely should go to bed. I don't want to start tomorrow too late. But see you in the next one. Hopefully a bit earlier than today. But yeah, anything else, reach out. See you in the next one.